Hello and welcome to Maths with Mr Amison. In this video I'm going to be looking at how we can practice using set notation. If you need to recap this topic then please watch Mr Chowdhury's video. I'm going to start by going through an example, talking through it, and then giving you time to copy it down and have a go yourself. Feel free to pause anytime. Okay, so it's worth pointing out that we have different notation here. A means set A dashed means the complement of A, it means the numbers that are not in set A. Okay, and AUB is A unified with B, A union B. Alright, it means the numbers that are in either A or B. If it's in A or if it's in B, at any point it counts. For the second, and for A and B, that's A and the intersection of B. The N being where A and B cross over. Okay, so it's only the numbers that are in both A and B. So we had the numbers 1 through 15. A was the even numbers, B was the multiples of 3. So the numbers in set A, the even numbers between 1 and 15, so 2 all the way to 14, counting in 2s. And the complement of A, or A dashed, not A, is the rest of them, the odd numbers between 1 and 15. Okay? So AUB, if it's in set A, or if it's in set B, altogether, if I go back a little bit, you can see this Venn diagram here represented the numbers all put into the Venn diagram. So AUB, the unification of A and B, any of those count. So all of the even numbers count and all of the multiples of 3 count. So we have 2, 4, 6, 8, 10, 12, 14 again, but we also have to include the odd multiples of 3 that weren't included in that, so 3, 9, 15. 6 and 12 were in both categories, so they're in there anyway, so that's fine. A intersection of B is the numbers that were only in both A and B, as indicated here, so the 6 and the 12. Okay, the even numbers that are also multiples of 3, between 1 and 15. Alright, your turn. See if you can have a go at writing which numbers are in each of these sets. And make sure you take the time to copy down the example and make notes if you need to. So in this question, again we have even numbers and multiples of 3. Again it's from 1 to 15 in our set here. So if we write down the numbers in set B, well that's all the multiples of 3 between 1 and 15. 3, 6, 9, 12, 15. The complement of B will be all the numbers that are not multiples of 3. So 1, 2, 4, 5, 7, 8, 10, 11, 13, 14. The unification of B and A, if I draw the Venn diagram for that, it's all of the numbers again that are in both B and A. Notice that's no different to A unified with B. We can write this therefore either way round and we still get the same result. Same with B intersected with A. It doesn't matter which way round I write them, I still get the same section, so I still get 6 and 12. Okay? So here are 11 questions for you to try. They do get fairly tricky towards the end. I have got the diagrams on the right here to try and help you remember what each of these things mean. See if you can have a go at writing down the numbers in each set. Make sure you do get the prime numbers right as well. Prime numbers, if you're unaware of the definition, try and think of it now. Prime numbers have exactly 2 factors. As long as you can't divide by anything except for 1 and the number itself, and it has to have 2 of those 2 numbers, it has to have 2 distinct factors, 2 numbers it can divide by, 1 and itself. It can't just be 1. Alright, So have a go at writing down the numbers in each of those sets. Alright, so to have the answers up here, in A is the even numbers between 1 and 15, so 2 through 14, all even. The complement of A, the odd numbers. B it would be the prime numbers, 2, 3, 5, 7, 11, 13. And the complement of B, the numbers that are not prime, 1, 4, 6, 8, 9, 10, 12, 14, and 15. The intersection of A and B, A intersection B, so the numbers that are in both A and B. If you look at this, the numbers that are in A, we have all of the even numbers. Now the numbers in B are prime numbers. Well, the only prime even number is the 2. So the 2 is the only number in both of those sets. So A and B is 2. Same with B and A. That's also 2. This one, the numbers that are in the complement of A, but also in B, that's the numbers in this set here that are also in this set. Alright, and you can see that we have 3, 5, 7, 11, and 13 there. Okay. Here, the numbers that are in the complement of B, so this set here, that are also in A. So that's all of the even numbers from here. So 4, 6, 8, 10, 12, 14. Okay. Here, the numbers that are in the complement of A and in the complement of B. The numbers in the complement of A, these ones, and the complement of B, these ones. So we have a 1, and we have a 9, and we have a 15. So that's it. Here, not in the intersection of A and B. Well, A and B first, that was 2. We got that earlier. So the complement of that is all the numbers that were not 2. So all the numbers up to 15 excluding the 2. And then finally, A unified with B, that's all the numbers that are in A and all the numbers that are in B inclusive. So that's all the even numbers and all the prime numbers. So 2, 3, 4, 5, 6, 7, 8. 9 is not included because that is not prime or even. Same with 1. And 15 again is not prime or even, therefore 15 is not included. But every other number there is either prime or even or both. Okay? Alright, so I hope you found that useful. It's definitely important to remember these definitions, and these diagrams are a really big help there. Alright, so keep trying, do your best. Bye for now.